Notes identifying conic sections. I wish we actually had more time to do conics in depth. I think Mrs. Byard, we wish we had more time to do conics in depth just because we would be in school and there wouldn't be a pandemic. But beside the point, my suggestion is write down everything first. So maybe go to the completed notes, write down everything on the first page, and then come back to this. So you've written down everything on the first page, you have come back to this, and we are going to move on. When we look at conic sections, we typically are placing two conics vertex to vertex to form that hourglass shape. Different types of cuts give us different types of sections, and we have circles, ellipses, parabolas, and hyperbolas. If we have a cut that is parallel to the base, which you can see on this first one, the blue line is my cut. Another way to say it, that's perpendicular to the central axis, and my central axis on this one is that black line. Central axis would be the same for every single one. I only drew it on the first one. We end up with a circle as our shape. If we have an oblique angle, so something that's not parallel to it, something that's not perpendicular to it, slanted, cuts through both sides of one of the cones. If we have an oblique angle to the base and the central axis, then we end up with an ellipse. A parabola is going to be parallel to the side through the base. And by the side, I'm talking it's parallel to that. If I was to extend it up, it would be parallel to that side as well. If it goes through only one of the cones, it's parallel to the side and it goes through the base, then we have a parabola. Hyperbola, it's going to be perpendicular to our bases, it's going to cut through both of our cones, and it's going to be perpendicular to the central axis. I didn't draw the central axis in on this one, but it would be in the exact same location, so bear with me. There would be my central axis, and you can see that these would be parallel. When we're looking at the general form and characteristics, I apologize if that's a repeat, I got distracted. We are looking at this same general form for all of our conic sections, regardless if it is circle, ellipse, parabola, or hyperbola. And so we are most interested in this aspect. We're going to start alphabetically and go by degree in descending order. So we have our x squared, then our y squared, x, y, and then our constant term. With circles, the thing that is the most important is that A is exactly equal to B. If you have the general form where your A is the same as your B, example, 2x squared plus 2y squared, then you know you have a circle. If you have A that does not equal B, and, this is key, and they have the same sign, so 2x squared plus 4y squared, then we have an ellipse. If either of your A or B terms does not exist, meaning that the A is 0 or the B is 0, then we have a parabola. Last one, which is similar to an ellipse. If my A does not equal B and my A and B have opposite signs, so that's saying one is positive and one is negative, it doesn't matter if it's A or B, then we know we have a hyperbola. And you can see down here this a little bit in action with the center radius form, especially on your ellipse and hyperbola. So with our center radius form and the characteristics associated with it, for a circle, we're going to have our perfect square binomial, x minus h quantity squared plus, and that's key that it's addition, plus my y minus k quantity squared, that's going to equal my radius. My center is h comma k, so if I have x minus 2, that means my center is at 2. And if I have y plus 3, then my center is at negative 3 there, so it'd be 2, negative 3. And then my radius is just my radius. This next one, you can see that I'm dividing by different radii, and they are both positive, so they have the same sign. My center is going to stay the same with that h comma k given the situation, and the r sub x, that's just saying that's the radius in the x direction or the horizontal direction, and r sub y is the radius in the y direction, vertical aspect. For parabolas, we're going to have y equals or x equals, and then it's going to equal some type of squared term. Your vertex is going to be your h comma k. And then this last bit, this hyperbola, remember we have opposite signs, which you can see here. I had a positive in front here and a negative. And then on the second one, I have a negative and a positive. I am still using the r sub x, r sub y, which is telling me I have different radii in the x and the y directions, respectively. Okay, on this one, if I am given my center radius form and I need to know what type of parabola, conic section I have, then I want to change from the center radius form to the general form. And the key here, in order to do that, we want to first, quote unquote, clear out the denominator. So we want to make sure that the denominator is 1 for everything. And to do that, we're going to multiply through by the least common multiple. With this first one, my least common multiple is going to be 16. So I'm going to multiply everything by 16. Distributing through, I'm left with x plus 3 quantity squared plus 16 divided by 4 is going to leave me with a 4. Y minus 2 quantity squared equals 16. I'm going to do this first section in red. I'm going to do the next section in black, and I'll leave the 16 as is for right now. This is telling me I have x plus 3 times x plus 3. When I FOIL this out, I'm left with x squared plus 6x plus 9. My next one. I don't want to distribute the 4 yet. I want to simplify my quantity first, and then I'll distribute the 4 through. Again, it's going to be y minus 2 times y minus 2. And then over here we have equals 16. Plus 4 times y squared, minus 4y, plus 4. And that's all going to equal 16. When I go through and I distribute, well, this isn't going to change. X squared plus 6x plus 9. I get 4y squared minus 16y plus 16. And then I want to move that term that was all the way to the right over. And since it was positive, I want to subtract it. This particular one, those are going to eliminate, and now I can write it in its final standard form. So I have x squared plus 4y squared plus 6x minus 16y, and then I'm left with just a positive 9 equals 0. In black, this is my general form. And since my A is 1, my B is 4, they're both positive. They're different terms. I know that this is an ellipse. This next one. My least common multiple is 9. So I'm going to multiply everything through by 9. When I do that, I'm left with x minus 7 quantity squared plus y minus 4 quantity squared equals 9. Again, I'll do this first term in red. I'll do the second term in black. X minus 7 times x minus 7. That gives me x squared minus 14x plus 49 plus y minus 4, y minus 4. That's going to be y squared minus 8y plus 16. Well, I can just subtract, I'll use a different color. I can just subtract that 9 from both sides, and I know I'm left with a 0 on the far right. which is part of the process. And then my final general form is going to be x squared plus y squared minus 14x minus 8y. So I have 49 minus 9 is 40. 40 plus 16 is 56, gives me 0. Again, this is my general form. My A equals my B, which is 1. So this tells me I have a circle. Try to do number 3 on your own. Pause it, come back and check and see if you get the same thing. So for number 3, my least common multiple is going to be 25. Distributing through, 25 times x minus 2 quantity squared minus y minus 6 quantity squared equals 25. We'll do the first part in red, second part in black, and then we'll leave the rest. So I have 25 times x minus 2 times x minus 2. That gives me 25 times x squared minus 4x plus 4, which gives me 25 x squared minus 100x plus 100. I don't want to distribute the negative through until I get to the very end. So I get subtraction. I'm subtracting that entire quantity of y squared minus 12y plus 36. And let's deal with this. I'm going to subtract the 25 from both sides on that second to last line. Distributing the negative through, I get negative y squared plus 12y minus 36, and then minus 25 equals 0. My final answer, simplifying it all out, I get 25x squared minus y squared minus 100x plus 12y. And then I have 36 and 25. Combining those, that gives me a negative 61. 100 minus 61 is a positive 39 equals 0. My A is 25. My B is negative 1. So this tells me I have a hyperbola.